Hello all, welcome to AtCoder Beginner Contest 382. We are solving problem D, keep distance. So in this problem, we are given two integers n and m, and we have to print all the integer sequence a1, a2 up till an of length n that satisfy the following condition in lexicographically order. So we are given ai, it should be greater than or equal to 1, and the subsequent elements, their difference should be at least 10. That is a minus 1 plus 10, then ai should be greater than or equal to that value, and they should continue from 2 up till n, and last value should be less than or equal to the m that we are given. Okay, and we have to give this in lexicographical order, that is they have to be sorted in order. So let's say we are given n and m, they have only given the one input for this, that 3 and 23. So we have to print an array of length n such that the maximum value that can have is 23 and the subsequent difference should be 10. Okay, so first of all, let's understand that how it is forming. So let's see, if my first value, what is the optimal case? That you start from the minimum one and then try to add those value subsequently, so that, and check that when you have reached the condition, how you can come back and backtrack and update the just previous elements and then continue with the same. So that is what the idea here is. Initially what I'll do is started with 1, in the next value added 10 to it, in next value added 20 to it. Seems fine, every condition is satisfied. One array we got. Next array, 1 will be there, 11 will be there. Now we had 21, that was a difference of 10 and 10. Now the second last element, the difference will be now 11. I will add 21 to it. Similarly, not 21, the final value will be 21. This will continue until I hit the last value as 23. When this will be done, that is the first 1, 11, 23. Now what I need to do is I will go and update my second last value. In that case, I will update, this was 11, I will update to 12. Now what I'll do is, when this is updated to 12, I will first just simply add 10 to it. So now it will be 22. In the next case, can I update this value? Yes, I can. So I will update it to 23. Now it has again hit the maximum limit. Now what we need to do, we again need to go back. I again went back, I checked, can I update it, increase it one more so that it will be valid? Yes, I can do that. I update this value to 13. Now what happens? Okay, again add 10 to it, it will be 23 again. Yeah, I can again add it to my value. Now since I have hit the maximum value, I have again go back. But going back, I have hit the maximum limit for the second last value also. So now I will again go back. Now I'll come to 1. I'll increment 1 by 2 because I can make sequence with 2 also. Now 2 plus 10 will be 12. 12 plus 10 will be 22. Yes, that is a valid sequence. It has not hit the end, so I can add one more element to it. So I added to it again one more element, it will be 23 again. So now I have 2, 12 and 23. Seems fine, but since I have hit 23 again, I will backtrack. I went back to 12. Now can I add one more element to it? Yes, I can add. So I added 13 to it and again continued the sequence. It went to 23 again. I can hit the maximum. Again, I will backtrack. This will be 13. No, it has also reached its highest. Again, I'll go back. I will get to 2. Can I add it to it? Yes, I can add it. How I'm making sure that I can add it? Because if you see, if 23 is the maximum, the second last value's maximum will be 13. Its third last value will be 3. So it will be the maximum value from m we will be decide, that is the modulus 10 part will be the max multiplied by 10 into the, that is the position that they have. Up till that we can have that value. So I can, this can be updated up to 3, this can be updated to 13, this can be up to 23. Similarly, if we had 37, this could be up to 7, 17, 27 and 37. So this is how it will go on. So we were here 2, so I can update it to 3. I added 3 to it, then added 10, 13, then added 23. So I have hit the maximum of all the cases. So this 10 will be our answer. Similarly, what we have printed out, the same is the output. Started with the 1 because we have to sort it in lexicographical order. So that is why, sorry, that is why it is printed like that, that it is sorted starting from 1 to all the cases covered, 2 to all the cases covered, 3 to all the cases covered. So this is what they expect from us. The initial thought process was that we can solve this problem using recursion. Why recursion? Because if we see the constraints, it were 12. So although it wouldn't pass up to 12 factorial, but since the very initial thought process is use recursion, so this was the recursive code that basically I started with. What I did, I basically passed n comma m and initially a vector empty vector of a, and la is the last value. Initially it will be something like -1 or anything, it can happen. So what I'll do is, a base case will be that if my a dot size hit n, if that is the case, I will simply push back my whatever the array I have in my answer. So I'll have to maintain another vector of vector as my as answer, where I will storing these sequences a. Okay, so I will push it back, I will return, I will remove from this loop. But if that's not the case, what I'll do is I will check it that if a is empty, I start with 1. Otherwise, what I'll do is I'll start with whatever the last value I have plus 10, and in that I will subsequently increment by 1 and 1. Okay, so if last value, whatever the last value I have, let's say 12 was my last value, I will push it back to my answer. I will call this recursive code, it will go there, it will again check, it will add 22 to it, then it will go back, it will add 32. Similarly, this will go again, I will come back here, it will pop that value because a recursive solution, 12 was there, it will be removed back, and next it will come to 13. So similarly, all the cases will be covered in this recursive code, but this will give us TLE because this 12 is very large number for us and it will exceed that limit, so we won't be able to do. So we need to figure it out some way. Can we do it using the loops? Yes. If you carefully if you carefully observe the sequence, uh, we will just try to uh, implement what we are doing over here. What I'll do it, I'll maintain a set is for the sorted, it will be pushed back in sorted order and all the duplicates will be removed. I will maintain a sequence. I'll start from 1 up till that is the modulus 3 value, that is whenever it does not hit that the maximum, that is 3 or 23, it is 3, so that is why initially I will initialize with that value for one loop. So for very first loop it will be 1, in the second iteration it will be 2, third iteration will be 3, and then loop over. Yeah. Now what I'll do, I'll initially start with adding 10 to subsequent elements. So first will be 1, 11, 21. Now I will insert that to my answer. Now I will iterate it through the array. What I'll do is the simply basically what I talked over here. I will see the last element. Is this element equals to the maximum value that we hit? If that's not the case, simply you go down there and increment it by 1 and add that to my sequence. But if that's the case, if it is hitting that case, you come decrement it by 1 and then you continue doing it for that. And when you are coming to, if it's the last value, it is very simple that if you are on this position, you are not hitting this loop, you are escaping out, and this is also case we are don't want, we are we will increment it by 1 and this will be the very last element, so we don't have any subsequent elements that will be updated. So that's not the case. But when we are over here, initially we were 11, now it got updated to 12. Now what I'll do is the subsequent values, that is the value coming that will be just after it, that values need to be updated. So initially whatever the 23 or 22 23 was the maximum when we were hitting it, when you were going back down there incrementing it by 1, this has to be also updated. So initially we'll start with the 10. Simply we got that answer. But after, when it is done, again can I increase my last value? That is why this continuation of this loop will continue and we will be continuously updating it for every proper index. So this is just what recursive code was doing. We were simply reduce it to the loops, and now that recursive calls and the context switching time, all that got removed, and this is just the simple implementation of how we were targeting to form our sequences. Simply after that, since it was a set, all the duplicate values will be removed, it will be in sorted order. We'll simply print that and we will go to each of the vector in the set and simply print it out, and then in the every subsequent line we'll do that. So yeah, that is all we have to do in this problem. If you have any query, do comment it out, do subscribe for more daily content, and hit the like if you like the video. Thank you.